Hello, and welcome to the webinar. Before we get started, I wanted to provide you with some initial housekeeping items. Today, we're using the Microsoft Teams Live Events platform to transmit this webinar. If you're not familiar with Teams, let me point out a few things. During the webinar, you'll have the opportunity to submit your questions using the Live Events Q&A feature on the right side of your screen. Anytime during this webinar, feel free to submit your question. At the conclusion of our presentation, we'll be addressing these questions with our panel. The audio is provided using your computer speakers. There is no dial-in number. Today's webinar is being recorded and archived and will be available on demand. If you're experiencing any technical issues, please refresh your browser or the Teams app. All right, with all that behind us, we can start today's webinar. And no better place to start than with some introductions. Hello, I'm Scott Mazon, the Marketing Director for the HEH Group, and will serve as the moderator for today's webinar. I have along with me Steve Lamar. He's the Director of Automation for Ultratech Automation. His extensive experience in robotic automation comes from his time at a major robot manufacturer where he served as both the engineering manager and corporate sales manager before joining the Ultratech team. I also have Mike Eller with us today. He's the Crotts Saunders Collaborative Robot Specialist and is on site at the Crotts Saunders showroom, standing by to demonstrate the Universal Robot Machine Tending application. Next, I want to talk real briefly about our organization, and more specifically the HEH Group. The HEH Group was formed by the owners of Ultratech Machinery, brothers Bob Haggerty and Jim Haggerty, along with Willie Eichly, the president of Mach & Eichly. The HEH Group is a family of companies with a mission to provide leading manufacturing solutions to the industry. By combining the strengths and resources of each company, the HEH Group is able to offer a variety of products and services designed to keep companies like yours competitive within their field. Today, the HEH Group consists of 5 companies. They are Ultratech Machinery, Ultratech Automation, Mach & Eichly, Crotts Saunders, and Advanced Spindle Technologies. With office locations in both Ohio and North Carolina, they're able to service job shops and manufacturers with automation, machine service and rebuilds, new equipment sales for both machining and metrology purposes, spindle repair, and a lot more. If you're interested in learning more about the HEH Group, visit the website, thehehgroup.com. So now let's start talking about what brought us all here to begin with. Utilizing collaborative robots for machine tending applications. Well, Steve, why collaborative robots? Why machine tending applications?
No, but before we go there, Scott, how about let's back up and let's answer the question, what is collaborative? So a collaborative robot it's a power and force limited device. What that means is when it comes into contact with something, an interference, it will stop, and it's then very easy to restart. What that does is it allows a person to safely work in a very close proximity to that robot, and they can do it safely, assuming that both the application and the process itself or the equipment are suitable for a collaborative process also.
So why machine tending?
Good question. So going into the virus, let's say, or prior to the virus, we know that there was a fast coming labor shortage. It was getting tougher and tougher because production utilization of machines was very high, and the labor was hard to get. Machine operators were hard to get. So I think coming out of it, it's actually going to be worse than it was going in. Once we continue with this, whatever shape the recovery is, it's going to get hard to get machine operators. So I think that's where automating is going to be a real good answer for that. The other thing that the automation will do for you is that typically in any automated process, the equipment is better utilized. It's running at a more consistent pace, it's running more often. What that means is you're basically a lot more efficient, your costs are lower, you're putting out more parts.
So the next question I have for you, Steve, is why collaborative in machine tending applications and not standard robots that you see?
The collaborative they offer a number of advantages over just the conventional automation. One is that just you have more freedom in design. Because there's a person or an operator in the area that can work safely with the automation, it eases the parts presentation to the system. So in other words, typically on an industrial robot application, you're justifying it based on labor reduction primarily, and then people like to talk in terms of how long will it run? How long of a part supply do I have feeding it that the system can run for 2 hours, 4 hours, 6 hours, 8 hours, whatever. Because an operator's in the area with collaborative, now you can cut that back. You can say, well, how many parts do I need to comfortably stage for the robot? And I can periodically go back and recharge or reload to keep it running. Maybe that's only minutes. Maybe that's only half hour, but it greatly simplifies the part presentation. The other thing is just with the safety fence. There's a lot less to the design of the system and a lot less to the floor space it takes up. So again, that's a huge advantage when you look at automating existing operations. Again, that goes hand in hand with that, less disruption to the existing processes in a plant, because you're not moving machines or moving equipment necessarily, creating more space for the safety fence and the working environment. Again, all tied hand in hand and going together. It's quicker to implement then, because it is easier, there's less equipment. It is generally lower cost, again, because you're implementing it quicker and there's less equipment. And then there's, again, going hand in hand with that, you get a quicker return on investment. If I can get it in sooner, get it running sooner, get a return sooner, it's all a good thing. The other thing that it does is that we look at the collaborative as not necessarily a labor replacement. We look at it as we're adding a resource. Again, a person is in the area. What could they be doing that's more important or better for them to do that maybe you can automate? So here they are, as periodically they're a machine or a cell tender, if you will, instead of a machine tender. Now they can go do something more valuable, inspecting parts, doing some other secondary processes. So you're basically adding more capability to your company, and again, at a really pretty nominal cost. The other thing with the collaborative robot, or looking at collaborative automation, is that it may allow you the opportunity to look at some areas or some processes that normally you wouldn't consider for automating, from a machine tending standpoint. So a few examples would be, for instance, some machining applications, you just have a problem with chips. Maybe you're creating the classic stringer bird nest problem, or you have a tool life issue. In other words, you can't run for an extended period of time without a person getting in there to do something to the machine from a maintenance standpoint. Well, with the collaborative robot, again, because it's an easier cell to get access to for a person to walk in and walk out and reboot, there might be an opportunity for you to do that, is to automate some process like that you thought you couldn't. Another area would be sometimes there's multiple machines in an existing line, and it's relatively tight spacing between machines, and where you really would need to push the machines apart to even fit in a conventional cell with the safety fence and with the larger part feeding and takeaway requirement. A collaborative robot is a much smaller footprint, and again, because it is collaborative, it's non-fenced, and you can get it in the area and work easily with it, and you don't necessarily have to disrupt anything around that current or that process. Another area would be in the low volume, high batch applications. So in other words, more of a job shop where I'm running fewer parts more often. Again, classic justification is I want to run lights out or run for an extended period of time. Collaborative, let's stage fewer parts, and maybe we change or restock more often. It's just a good low-cost way to open that opportunity to a lot of the smaller shops, is that you can start looking at those applications. Multiple machine applications, another one. The larger automation systems, in some cases, just the way the process is, you might be tying a number of machines together, redundant processes, but you might have one robot tending multiple machines. It could be overhead, it could be floor mounted, it could be a large reach robot. The problem with that is it gets very difficult to guard the machines individually to allow a person to access any one of the machines for maintenance or for whatever reason, so that what you create is a one down, all down. So let's say you have 4 machines inside a safety fence enclosure. Something happens to one of those machines that needs some minimal tending, minimal attention for an operator, you're shutting 4 machines down. You're taking them out of production for a period of time. So what is maybe a 5-minute on one machine just turned into 20 minutes of lost production machining time. Collaborative, again, you can probably costs justify it just based on the difference in fence, but using a collaborative robot at every machine now affords you that opportunity that it's not a one down, all down. It's an individual redundant cell. And again, a lot of times the cost difference between this extensive safety fence to allow you to gain access to machines individually in a larger cell versus an individual collaborative robot, it can be a wash or very close. And you gain the redundancy. Another area would be on the maybe the shorter runs on multiple machines. So in other words, I may have a turning process, I may have a milling process, two different machines. It's hard to justify conventional automation on either one of those. Collaborative robots can be easy to redeploy. We make ours so that they're portable, they're mobile, and we have different methods of docking or registering that system to a different machine. So again, you could run for a half a day on one machine, you can move over, run a half a day on the second machine. And then lastly, basically there's just a lot of good things going for it. So, the bottom line is if you're thinking of automating, you really need to consider the collaborative side of it. Again, it's adding a resource, it's making your operations more efficient, and efficiency means money.
So Steve, when somebody is looking to add automation to a machine tending application, what should they be looking for?
Well, I'll talk about our approach. The first thing we do is we'll broaden the definition of a machine. So it's not just a quote-unquote machine tool or a CNC control machine. It is an automated piece of equipment that somebody is tending. It performs an automated process. There's an operator there. What we'll do is we'll usually do a walkthrough in the plant and talk with the customer. We'll look for production areas that have known issues. Are there some ergonomic problems? High turnover with people, it's just tough for a person to do. Are there part quality issues, throughput issues, uptime issues in that area or in that cell? That kind of can pinpoint you to an area that really should be getting attention. And then after that, we'll start also look at, is there a decent size part run? In other words, we talked about the low volume, high batch. Okay, that has to be within reason. So are we talking about similar part families that you can get a part run of dozens of parts or hundreds of parts, not necessarily thousands. So we kind of look for that also. Then we'll look at once we've identified that, we'll look at the part presentation. Is there a way that they can easily be presented to the automation? Can they be staged simply? Can they be presented in trays? Could they maybe a simple conveyor? Primarily at the beginning without a vision system, let's keep it as simple as possible. And then we'll look at the machine itself, that piece of equipment. Is it ready for automation? From a, not necessarily the door open or close if that's automated, because we can usually deal with that, but from the work holding. What's holding the part or the part fixture? What about the chips that are created in the process itself? We talked a little bit about that earlier. What about the interface to the machine? How is the automation going to tie in, interlock-wise, that handshaking I/O? So we'll take a look at that. And then really lastly is we'll look at the cycle time requirements. You want to have a balance between the load and load time of the automation and then what is the actual process rate, that machining time for the part. It has to make sense. The real quick machining rates, you're going to be longer on the load unload, and it probably won't make sense at that point. There has to be a good balance there.
Is that a functionality of the robot itself?
From a cycle time standpoint, there's a lot of things that go into load unload time. It is that interlock or that handshaking with the machine, what's involved with the fixture, and then it's actual physically how quick can the robot get in, grip a part, get it exchanged, and get out. And then you also add in potentially the door open close time. So in a lot of cases, we'll use maybe as a ground rule, if that's 6 to 8 seconds, typically that kind of gets it's a candidate for automation, or that could make some easy justification sense, if you will. If it's quicker than that, then you start to think about it. Okay, we either come up with a different way, or it's just not necessarily the right answer.
So as manufacturers and job shops start exploring automation and for their machine tending applications, what are some of the roadblocks that can pop up or need to be overcome?
Well, let's start at the high level first. There's really, I think, two areas there. One would be lack of experience. And by that I mean the robots themselves are very easy to operate, but the actual identifying of an application, the right candidate for the automation, and then defining the best approach for that isn't necessarily easy. And that's where you can go wrong or down the wrong path. The second roadblock I see, high level, would also be the lack of resources. So maybe they have people with the capability, but again, thinking of the resource shortage that we talked about earlier, maybe they can't assign a person to do that, to do what it takes and actually implement an automation cell. So I had said high level for those first two roadblocks. Then I think there's also what I'll call, let's say, the lower level. And by that, I would mean things like maybe they chose the wrong application, went down the wrong path. It really wasn't that suited for automation. The other problem we see quite often, even in just general automation, is just trying to do it all. In other words, maybe you can satisfy 90% of their production, 90% of their volume, but they have this other 10%, and everybody wants to do that 10%. And what it does is it potentially could kill justification for the automation that could get you a benefit for the 90%. So I call that as you're trying to do it all, all parts, all processes, all the time. In a lot of cases, you don't have to, and it doesn't make sense, where you could be seeing a return on a portion of that. Another one would be is just the wrong approach on the part presentation, especially on the collaborative side. Again, change the mindset that I don't need to run for hours to be able to justify this. I just need to be able to run it and keep it fed. So how can I do that, knowing I have an operator in the area? And then lastly, in a lot of cases, it's kind of like the shopping list. Is once you figure out you've got a couple dollars left over, well, what else can I do with it? So you continue to add more and more processes. What if we did this? What if we did this? What if we did this? And again, I've seen it happen many times that if you can't do it all, well, let's just not do anything.
So, Steve, at the risk of sounding like a sales pitch, how are we helping manufacturers bring automation to their machine tending applications?
Yeah, our focus, especially on the collaborative side, was really is to address those higher level roadblocks that we talked about a minute ago. That is the lack of experience. So we work with the customer. We help them identify the right application for a collaborative robot. And then we wanted to make it easy for them to implement or define that best approach. And then also help them with the lack of resources. Maybe they just don't have the people or necessarily the right people. So we created a number of different support packages that are either hardware-based, labor-based, or a combination of both, and we refer to them as a cobot combo because we work with the customer like a grocery list. Let's pick and choose where you need the most help. What you'll take on, what we'll take on, with the goal being is it's the right application, it's done the right way, and we get it in as quick as we can so that they can get the ROI and they're successful. That's the bottom line.
Steve, what robot companies do we work with?
Well, for three of the sister companies within the HEH group, we are a certified systems integrator for Universal Robots. For Ultratech Automation, we're also a certified Fanuc Robotics and Yaskawa integrator.
Thanks, Steve, for sharing those insights about collaborative robots and utilizing them in machine tending applications. Now I'd like to turn it over to Mike Eller, who's standing by at the Crotts Saunders showroom, ready with our live demonstration. Mike, are you there?
Hello, I'm Mike Eller. I'm a collaborative robot specialist for Crotts Saunders Automation Division. Today, I'm going to be running a machine tending demonstration featuring the Universal Robot 10E Series Cobot. This robot is common for machine tending applications because of its 51-inch reach and 22-pound payload. That being said, the Universal Robot currently offers 4 different payload options: the 3, 5, 10, and now 16. For today's demo, we have paired the 10E with the Perco BM10i CNC vertical milling machine. So let's get it started. I will now start the demo. We're able to automate the door using the UR robot. If cycle time's an issue, we have other options to automate the door. Next, the shunt coax gripper will pick up the blank and load it into a pneumatic work holding fixture inside the Herco machine. After machining, the UR robot will unload the finished product from the fixture and place it back into the parts tray. As you can see, this demo can simplify the machine load and unload process, freeing up your workforce for other areas. If you think adding automation could benefit your shop, reach out to us and we can set up a personal demo at your facility here in our showroom or online.
Thanks, Mike, for that demonstration. As you can see, the UR robot was able to effectively handle the machine loading and unloading of the Herco. I want to point out that UR is sitting on a portable base and is an option with our Cobot combos. Since we're approaching the 20-minute mark, I want to briefly touch on ROI and a few things to consider when making those calculations. When putting together your cost grid to justify the investment of a Cobot, it's common to take the cost of the robot and divide it by the monthly salary of the worker. That's a good starting point, but take into consideration other employee-related expenses like safer work environment, medical insurance, increased efficiencies, and savings in raw materials with greater stability that comes from using a robot. These are just a few things to consider when you're putting together your cost grid. Pair that with the low cost of a Cobot, and justification becomes a little bit easier. Also, I want to point out the Robot Industries Association has a good online ROI calculator that you can check out by going to robotics.org. Well, that brings us to the conclusion of our webinar today. Before we get to the Q&A, I want to thank everyone for their time and attention and hope everyone stays safe during these unprecedented times. As Mike mentioned in his demonstration, if you'd like a personal demo at your facility, at the Crotts Saunders showroom, or even online, feel free to reach out to us and we'll set something up.